Oh, thanks, Kev. All right, here we go. So, guys, I left you on Wednesday talking about these nth root radicals and saying how we're going to work with square roots again first before we get into other roots, like third roots and fourth roots and fifth roots, right? Because, guys, the square is not the only power we have. We have third powers and fourth powers and fifth powers. So we need a way to undo those powers as well. So we have other roots other than square roots. You probably just haven't worked with them all that much. So let's go back to where we left off on Wednesday with our square roots. I told you on Wednesday that those problems are going to get bigger. So I'm going to show you the bigger square root problems today. And then when we come back from our glorious 3-day weekend, we'll look into third roots and fourth roots, which hopefully will just feel that much easier once you see how the square roots are applied, okay? All right, so on Wednesday, we did problems like this. Let's go back and review. So if I ask you to take the square root of x to the 16th, right? Please remember that if there is no index or root written in this little corner, it's assumed to be 2. That is the square root symbol, guys, okay? There is no first root. If nothing is written there, it's assumed to be 2. All right, so if I want to take the square root of x to the 16th, well, remember, a square will undo, a square root will undo a square. So really, to take the square root of x to the 16th, I have to figure out, well, how many x squareds can I make out of x to the 16th? Because I'll be able to square root each one of those x squareds to get an x. So the shortcut, instead of you having to break this down into a bunch of x squareds, I told you, just do this. If you're trying to figure out how many groups of 2 you can make out of 16, then it's going to equal x to the, take the power, 16, and divide it by the root, the number of groups you're trying to make, right? So in this case, it would be equal to x to the 16 divided by 2. How many x squareds can I make out of 16 x's? Well, guys, 16 divided by 2 is 8. You'll be able to make 8 of them, which means you'll be left with 8 x's, which means you'll be left with x to the 8th power. So the square root of x to the 16th is equal to x to the 8th. So the shortcut was to take your power and divide it by the root. All right, so we saw that on Wednesday. Then I showed you, well, if you're going to take the power and divide it by the root for the shortcut, what happens if the power doesn't divide by the root? Well, guys, then I warned you. If the power doesn't divide by the root, then you're going to be left with something left over that is stuck underneath that radical. You're not going to be able to break everything free of the square root. So if I asked you to take the square root of x to the 11th, you would say, okay, that's x to the power 11 divided by a root of 2. But 11 doesn't divide by 2. And we do not want to make a fractional exponent yet. Guys, it's coming. We're going to work with fractional exponents, but not yet. And I don't want a decimal. I don't want 5.5. So that means I can't technically take the square root of x to the 11th. I have to simplify it, which means we got to break it down. So I told you to do this. We're going to break x to the 11th up. Think about it. What's the closest number to 11, without going over, that divides by 2? 10. So we're going to break that up into x to the 10th, something we will be able to take the square root of. And then what's the leftover? X to the 1st gets you back to x to the 11th. So guys, I haven't changed the problem. This is still the square root of x to the 11th. But now you'll be able to split them into the square root of x to the 10th times the square root of just x. You can break them up into their own square roots. So now I can take the square root of x to the 10th. The square root of x to the 10th is going to be x to the, what's 10 divided by 2? 5. So he's x to the 5th. He's free. No more square root. Can I take the square root of a just x? No, he was the leftover, right? So he's the part that's going to be forever stuck underneath that square root. We can't break him. I just punched myself in the face. We're not going to be able to, I was like doing this. We're not going to be able to break him free. So this is your simplified answer. So the square root of x to the 11th becomes x to the 5th times the square root of x. What you got? Oh, no problem, Jack. Thanks for the heads up. All right, so that's what we did on Wednesday. Now all you guys have to do is you have to take these little mini problems and apply them on a much bigger scale. So let's look at some bigger problems, all right? So look at example 1. I'm just going to move mine up a little bit. Okay, so right now you're asked to simplify. the square root of this expression. So guys, first of all, recognize that this is the square root again, because in the future, we're going to be working with all different kinds of roots, thirds, fourths, fifths. You should always be recognizing, all right, what root am I working with, to kind of put you in the right mindset. All right, so it's a square root. The way I would handle this, since everything underneath the square root is attached by multiplication, there's no adding, there's no subtracting, making this a much more difficult problem. Since everything's attached by multiplication, let's split it and write everything underneath their own square root so we can deal with this on an individual basis. So I'm going to rewrite this as the square root of 64 times the square root of x to the 12 times the square root of y to the 4th. All right, I'm allowed to do that since they're all attached by multiplication. And now you can kind of handle it one at a time. All right, so let's go to the square root of 64 first. Guys, what's the square root of 64? Is that a beautiful number or what? Yeah, it's 8. Beautiful. It's a perfect square. All right, what's the square root of x to the 12? Does 12 divide by a root of 2? Yeah, it's x to the 6th. He's free. No more radical. He's a perfect square. Can I take the square root of y to the 4th? Does 4 divide by that root of 2? Yeah, what's 4 divided by 2? It's 2. That's going to be y squared. So everything involved in this problem was a perfect square. Everything underneath this square root was something that I was able to square root. So I'm left with a beautiful answer, 8x to the 6th y squared. So guys, believe it or not, when you square root something, I'm trying to figure out what did I have to square times by itself twice to equal that. This. If I times this by itself 2 times, I'll get 64 x to the 12 y to the 4th. It's beautiful. All right, so that worked out nicely because everything was a perfect square. But guys, we know math. Is everything going to be that easy? No, but it's a nice one to start with. All right, so let's look at example 4. All right, let's say you're asked to take the square root of 18 x to the 3rd y to the 6th. Well, first I've noticed it's the square root, and I noticed that everything's attached by multiplication. So guys, let's split it. Let's write everything under its own square root so I can work with it at an individual basis. So I got the square root of 18 times the square root of x to the 13th times the square root of y to the 6th. Now let's deal with it one at a time. All right, so if I go to the square root of 18, guys, is 18 a number that I can square root? No, it's not a perfect square. But is it simplifiable? Is there a biggest perfect square, a number that I can square root that divides evenly into 18? Yeah, so we can fix this. So we're going to split them. We're going to split them up into something I can take the square root of and something that I can't take the square root of. So we're going to split them up into the square root of 9, that's my perfect square, times the square root of the leftover, which is 2. And just leave it. We're going to keep on going. All right, let's go to the next one. Can I take the square root of x to the 13? Does 13 divide by 2? No. So we're going to have to split him. Bless you. So what's the closest number to 13 without going over that divides by 2? 12. So we're going to split him into the square root of x to the 12th times the square root of how many x's are left over to get you to that 13? 12 and just 1. Normally, it's always 1 that's left over with a square because every other number divides by 2. So you should only have 1 left over. All right, and then last, can I take the square root of y to the 6th? Does 6 divide by 2? Yeah, he's actually quite beautiful. We don't have to do anything to him, but because I am like OCD, I like to take my square roots all at the same time. So since he's ready to go, I'm just going to leave him as is. I'm going to take his square root in the next step when I start taking my square roots. But if you wanted to write y to the 3rd right now, you could. I'm just going to hold off one more step. But I don't have to do anything to him. He's ready to go. All right, now this is what I would call, I know, very technical word, the fun step, okay? The fun step is, this is where you get to go through, take away the square roots that you can take away, break things free, and then leave the square roots that have to stay. All right, so one at a time, let's go through. Guys, what's the square root of 9? 3. He's free. No more square root. A lot of students every year have a horrible habit. They take the square root of 9, they know it's 3, but they put it back under a square root. Please don't do that. You got 3 because you took the square root of 9. The square root's gone. The answer is 3. So don't be like putting stuff back under a square root that's not there anymore. All right, can I take the square root of 2? No, he's the leftover, so leave it. All right, go to the next one. What's the square root of x to the 12th? What's 12 divided by 2? It's x to the 6th. He's free. He divided. No more square root. All right, go to the next one. Can I take the square root of just x, that leftover? No, so he has to stay. And then the square root of y to the 6th, guys, we already said he was ready to go. The square root of y to the 6th, what's 6 divided by 2? It's 3. So he's y to the third. He's free. No more square root. So guys, technically, very technically, you're done. This is your answer. We just got to clean it up and write it in a nicer order. So what you're going to do now is anything that's not under a square root, you're going to multiply it together and write it in front. Anything that is under a square root, you're going to multiply it together and put it back under one square root. So what's not under a square root anymore? 3 times x to the 6 times y to the third. That's 3, x to the 6, y to the third. Done, done, done. Now, anything that is under a square root, multiply it together and put it under one square root. So that's going to be the square root of 2 times x, which is 2x. Done and done. And now everything is where it needs to be, and that's your answer. The square root of this is that. That's what it simplifies to. So this is what you'd have to multiply by itself 2 times to equal 18x to the 13th, y to the 6th. All right, how did that feel? Guys, it's definitely a process, and I see that it's a lot of work. But I'm telling you right now, every year, the students that are willing to do this process and stay organized and neat are the ones who are least likely to make a mistake. For all those students that want to do stuff in their head and skip steps, they are more likely to miss something and make a mistake. So as much as of a process as is, it is a process I do think you should be doing. All right, let's try example 5. All right, so number 5 is a little bit different in the sense that now you have this 5x squared that is attached by multiplication to the front of this radical. Guys, it just means 5x squared, he's just hanging out, waiting to be multiplied with anything that you break free. So you are so not ready to use him yet, we're going to carry him down quite a few steps. So just bring him down, make him wait his turn. We are not ready to use him yet. We got to simplify the square root first. All right, so we're going to concentrate on the square root of this. So since everything's attached by multiplication, I'm going to split everything and deal with them one at a time. So we're going to times it by the square root of 12, times the square root of x to the 7th, times the square root of y to the third. And then one at a time, let's break it on down. All right, so yet again, bring down the 5x squared. He is just hanging out, waiting his turn. All right, let's go to the square root of 12 first. Can you take the square root of 12 and get a whole number? No, it's not a perfect square. Guys, maybe he's a simplified radical and we'll just leave him the square root of 12 and nothing can break free. But is there a biggest perfect square that divides evenly into him? There is. 4, right? So we can break it up into the square root of 4 times the square root of the leftover. Who's the leftover? 3. He's the number that we're not going to be able to square root and he'll be stuck. All right, now we go to the square root of x to the 7th. Can I take the square root of x to the 7? Does 7 divide by 2? No. So what's the closest number to 7 without going over that divides by 2? 6. So we're going to split him. We're going to split him up into the square root of x to the 6 because I'll be able to take the square root of that and times the square root of how many x's are left over to get you back to 7? 6 and just 1. All right, now we go to the y to the third. Can I take the square root of y to the third? Does 3 divide by 2? No. So what's the closest number to 3 without going over that divides by 2? 2. So we're going to split him into the square root of y squared times the square root of how many y's are left over to get back to that 3. Just 1. 2 plus 1 is 3. Woo! So if you ask me, hard part's over, right? We broke it on down. Now it's the fun part, Kyle. All right, now we get to go through, take away the square roots that can go away, leave the ones that have to stay. All right, so 5x squared. Come on down again. All right, square root of 4, 2. He's free, no more radical. Can I take the square root of 3? No, he was the leftover. I can't simplify him. I can't take the square root. He stays, square root of 3. All right, the square root of x to the 6, 6 divided by 2 is 3. That's x to the third. No more radical. He divided. He's free. Can I take the square root of a just x? No, he's the leftover. He stays. All right, guys, this is our baby. The square root of y squared. Squares and square roots cancel. We're just left with y. 2 divided by 2 is 1. It's just y. And then can I take the square root of a just y? No, he was the leftover. He's stuck. He stays. All right, now we get to go through and we multiply anything that's not under a radical together and anything that is under a radical we multiply together and put under a radical. Well, guys, remember, math has a specific order they like things in. First, we should look to multiply our numbers that broke free. Then we should look to multiply our x's that broke free, and then we should multiply our y's that broke free. They like you to be in alphabetical order. All right, so let's do numbers first. I have a 5 free times a 2 times no other numbers broke free. So that's just 10. 5 times 2. He's done. He's done. All right, next we should be looking for our x's that broke free. Let's multiply them. X squared times x to the third broke free, so add their exponents. 2 plus 3 is 5. That's x to the fifth. And no other x's broke free, so that's x to the fifth. Done, done. Remember our exponent rules. When you're multiplying, you should be adding your exponents. All right, now I'm looking for, I know I got y's, so look to see if you have any y's that broke free that you can multiply together. No y's, no y's. I got one y free, and then no other y's. So that's just going to stay y. We have nothing to times him with. All right, so everything that is broken free is taken care of. Now we're going to go through and multiply anything still stuck together and put it under one square root. So that's going to be 3 times x times y. 3xy. And then he's done, and he's done. And you're good to go. How do you guys feel? Are you okay? Again, like I said, it's a process. I will never argue that. But it's definitely something you guys can do. All right, I'm going to let you guys try the last one. I'm going to give you a head start. I'm going to double check the attendance, and then I'll start chiming in a minute or two. But you guys try this one. Don't force anything. If something is already a simplified square root, just enjoy it. It's less work for you. So I wrote up Tuesday's notes. 17 examples. Well, I think I should use letters because letters look like I didn't do 17. What you got? Oh, sorry.
This is why you were.
That's why I have problems. This is why some kid says to me in third period, he's like, "That's why you always just seem like you're rushing." My whole life is rushing. I'm always late. I'm never on time, so I'm always rushing. And then it's like I always want to do just one more thing. Right. Let me just do one more thing. Right. So I am always rushing.
I think before quarantine, you had cut back.
I did. Yeah, quarantine.
Then it was like unlimited time.
In quarantine, I'm like, oh, I got a video. I'll make it 45 minutes long. I just keep doing it.
Yeah.
I know. It's hard.
I'm the same way with like, I want to mention this fact. I want to mention.
Yeah, that's what I feel like.
Like,
they see this in the homework. Right. This in the homework.
Like, they don't care.
Well, I guess I just.
The basics.
Oh.
I'm like, oh, maybe this might help.
I know.
Maybe this basic.
Mm-hmm. That's at least what I would have done to get started. Break it all up. You'll hit one piece at a time. At negative 2y to the fourth, he's just hanging out, waiting to be multiplied with anything that breaks free.
I don't know if you're stretching or if you're like,
Yeah. Stretch?
No, question.
It is 100% perfect. The only thing I would say it doesn't have might nitpick on, and I don't know the answer to this, is they may make you put x and then y to be alphabetical. It should not mark you wrong because the order in which you multiply doesn't matter, so it's not wrong. We just like things to be alphabetical, but it is right. What's that? Oh, oh God.
How did they get the number? Bro, I was like, just make this one up. I don't know how to do it.
Run the mirror real quick. He's down there.
Leave it like
All right, we got the square root of 10 Guys, no perfect squares divide evenly into him. That's beautiful. It's less work for us. We're not going to be able to break anything free. The square root of 10 has to stay. The square root of x squared, that's our baby, right? The square root of x squared, that's it. They cancel. That's x. The square root of y. I got so excited. Sorry. The square root of x squared, he is our baby, but I'm going to wait until the next step to take the square root of him. All right. The square root of y to the 15th, we can't take the square root of that because 15 won't divide by 2, so let's split them up. The closest number to 15 is 14, so I'll break him up into y to the 14th times y to the leftover is just 1. And then the square root of z, guys, a power of 1 and a root of 2. 1 doesn't divide by 2, and nothing smaller than 1 divides by 2, so he's already simplified. You're not breaking anything out there. He's going to stay the square root of z. All right, now the fun part. All right, so negative 2, y to the 4th. Square root of 10, he's stuck. We can't fix him. The square root of x squared, they cancel. That's just x. The square root of y to the 14th, 14 divided by 2 is 7, so that's y to the 7. The square root of y was the leftover, so he's stuck. And the square root of z, we said, is stuck. All right, now we go through. Numbers first. Negative 2 times no other numbers broke free, that's going to be negative 2. Done. Technically, I'd understand if you went to do your y's next, but they like things to be alphabetical, so I'm going to go do x's next. So any x's that broke free, I got 1 and no others, so that's just going to stay x. Now I'll go do my y's. Y to the 4th times y to the 7th broke free, that's y to the 4 plus 7 is 11, and no other y's. And then they're done, and now what's left under the square root can be multiplied together. So then that will be the square root of 10 times y times z. And that would be your simplified answer. Done, done, done. Okay, how do we feel? Good? All right, hopefully this feels good because it's square roots and we like square roots. When we come in on Tuesday, we're going to do the exact same thing, but with third roots, all right? All right, at home, thumbs up, you're okay? All right, if you don't have any questions, guys, I did create a homework. You have not had a homework on this yet. I know it's a weekend, I apologize, but I need you guys to practice this. So I made it, it's a Delta Math assignment. It's 8 questions, but it is not due until Monday night at 11:45. So you have the whole weekend. I want it done though before we come back so that when I give you Tuesday's homework, you don't feel bombarded. So guys, do a couple questions a day and you'll be done. All right, so it's on Delta Math, 8 questions due Monday night, 11:45. All right, guys at home, enjoy your 3-day weekend, and we will see you on Tuesday.